Hello, maurieo, and in this instructional video we're going to find the equation of this curve. So just before we start, what sort of curve is it? Well, yes, it's a parabola. Yes, a parabola. And this one is a positive parabola because it's up that way. If you put it out in the rain, it would catch water. So that's positive. And if you tipped it up the other way, put it out in the rain, it would shed water, and that's negative. So let's get some sort of words for this. So here it is. Our curve is a parabola, and it's positive. That can only be good. All right, so the standard equation for a parabola, or one of them, is y equals a, capital A, and in a bracket x minus little a, and another bracket x minus little b. Now, the parabola is always associated with the quadratic equation, or it has, the highest power in it is to the power of 2. So typically, x squared or something squared, but no higher power. And so that means that there is what we call two roots where there are real roots. Now you can see in this case here, the parabola intersects what we call the x-axis, which has the equation y equals 0, and the intersections are at the 2 points shown there, -1, 0 and 3, 0. So you can see that in both instances y is 0. So it intersects the x-axis at -1 and 3, and they are typically the roots of the equations there. And then it also intersects the y-axis at 0, so that's where x equals 0 at -1. So you can see that, if you can imagine that shape can translate anywhere all around the Cartesian plane there. So it is possible that the parabola could be above the x-axis and that it didn't intersect the x-axis at all. And in that case, we say it has no real roots. And we do have a different form of the equation that we can use for that one. But obviously, this one here, it doesn't quite cut the mustard. So moving right along. So you might think, when get on with it. We just want to see the answer. Well, this background stuff is very important in that, and when you come and look at another problem, that you need to have this foundation, this depth of knowledge in there, so it helps you to understand what I'm going to say going forward. So that's why I emphasize it a little bit, because it broadens the knowledge. Okay, so when y equals 0, x equals -1, as I have explained there. And therefore, if you said, well, -1 minus a, just using that little, the little bracket there, x equals 0, that must be the case because, for y to equal 0, one of those multipliers, x minus a, or one of those factors as we call them, x minus a, x must be 0. So we'll just put -1 for x minus a equals 0, and then we can see, well, a equals -1. A equals -1, right? And also we can say, well, x equals 3 there as well, and we put 3 minus b. It doesn't matter which one's a and which one's b, to be fair. 3 minus b equals 0, and b equals 3, obviously, as you can see there. So we can put all that together and we can say that y equals a to the x plus 1, a times x plus 1 times x minus 3. And there are, we call them the two factors. A is sort of a scaling thing. So, I mean, the parabola can be skinny, or it can be a skinny one or a wide one. So we need to know how much it is. The standard one is y equals x squared. And the upside down, or the negative one, y equals negative x squared. But the a gives us that scale. So now we've used the 2 bits of information there. We use the third bit of information, and we say, well, when x equals 0, y equals negative 1. So let's put that into the equation. Negative 1, therefore, equals a times 1, because x times 1, because x is 0. So 0 plus 1, 1. 0 plus minus negative 3, negative 3. And there we have it there. And working through with that, we can say, well, negative 1 equals negative 3a. And if we divide by negative 3, we get a equals a third. So now we've got a, we can put that into our equation, and we get y equals a third, x plus 1, bracket, a third, bracket, x plus 1, bracket, open bracket, x minus 3, close the bracket. Now we can expand all that out. The x times x squared, x times negative 3, 1 times x is x, and that'll give us negative 2x, and plus 1 times negative 3, negative 3. And then we can divide all that by a third, which is what I've done, and we get this another form of the equation, x squared over 3 minus 2x over 3 minus 1. And there is, in fact, a third version of the equation, which I haven't shown here. And that gives us is able to give us the coordinates of the vertex. Now the vertex is this low point of the equation right there. It's the low point of the equation right at that point there. That's called the vertex. And there is another form of the equation that sort of easily tells us that, but we'll save that for another day. Very good. Well, good. Cheers. That's it. That's all you need. Bloody marvellous.